This issue explores how object motion occurs. How exactly does movement come about? Before Galileo and Newton, people's ideas about the motion of objects come from Aristotle. In Aristotle's opinion, that is, in a perfect position. Objects tend to remain in a perfect position, so, in general, objects are fixed in their natural position. Once removed from its natural position, the object then tends to return to its natural position. He thinks that this natural position is the state of rest. That is, objects usually remain at rest. It only moves when subjected to force or impact. This is evident in Aristotle's conception. Force is what sustains the motion of an object. Then from the same height, when throwing feathers and pieces of iron at the same time, which one will land first? Aristotle thought that the iron must have fallen first, because the heavy object is subjected to a greater force that pulls it towards the earth. It looks very much in line with people's intuitive thinking. That is, heavy objects fall faster than light objects. Outside the heavy objects fall faster point of view, Aristotle also stubbornly believed that it was only pure thinking. There is no need to test it in practice, because of his view for a long time. Whether the weight of the object does fall at different speeds until the advent of Galileo. It is said to be to verify Aristotle's view. Galileo Galilei once experimented with the release of heavy objects on the Leaning Tower of Pisa. Aristotle was ultimately proved wrong, although the credibility of this story is very low. But Galileo did do some experiments on this. Galileo did an experiment similar to the vertical fall of an object. That is, objects of different weights are rolled down a smooth bevel. At this time, due to the falling of the object, the velocity is smaller than when falling vertically, so it's easier to observe. A simple example illustrates Galileo's experiment. At a horizontal interval every 10 meters, a small ball is released on an inclined plane that descends 1 meter. It doesn't matter how heavy the ball is. After 1 second, the velocity of the ball is 1 meter per second. The velocity of the ball after 2 seconds is 2 meters per second, and so on. So Galileo's observations show, it doesn't matter what the weight of the object is. The rate at which their velocity increases as they glide down the inclined plane is the same. That is to say, Aristotle, the conclusion that heavy objects fall faster than light objects, is wrong. The feather and the iron should have landed at the same time. Of course, in real life we will find out. Iron does fall faster than feathers. This is due to the presence of air resistance. Air resistance reduces the velocity of the feather. If we release two objects that are not subject to any air resistance, well, no matter how much they weigh, they always go down at the same rate. This conclusion was subsequently confirmed. Astronaut David Scott, in the absence of air resistance, experiments on feathers and pieces of iron were carried out on the moon. It turned out that both did fall on the surface of the moon at the same time. From this it is understood that force is not what keeps an object moving. Rather, it is the reason for changing the velocity of the object. It is on the basis of this experimental conclusion of Galileo. Newton began to think and study more deeply, and eventually came up with the famous Newton, the three laws and the law of gravitation.